Next we are going to see our second experiment, design and testing of integrator and differentiator. Here we have to obtain the performance of the integrator as well as differentiator. We have to the input as a waveform and the output will be another waveform for the integrator and differentiator. Okay, regarding the integrator, the output voltage V0 is equal to -1 divided by R1 CF integration of 0 to T VI dt. VI is the input voltage and we get the output voltage as the differentiation of input voltage. For the differentiator, the output voltage is equal to minus RF into C1 into VI divided by Vt. Here the input voltage is differentiated and it produces the output voltage. Next, this is the design for the integrator. We are going to take the value of R1 as a 10K and RF equal to 4K and CF from the formula C equal to 1 divided by 1 by RF. We can substitute the value as for the frequency as a 4K. Right, we can take this as a common term for RF is equal to 10R, from which we can calculate the value of RF. Therefore, RF is equal to 10R means 10 into my R1, that is 10 into R, which we can take the value as 100 kilo ohm. Therefore, RF is equal to 100 kilo ohm, R1 equal to 10 kilo ohm, F equal to 4 kilo ohm. Therefore, we can calculate the value of CF, where CF is equal to we can take the CF value as approximately equal to 0.01 microfarad. This is the design for the integrator. Similarly, for differentiator, the formula we have to take here is RF is equal to 1 divided by 2 pi C1 into F1, where C1 is 1 microfarad and F1 is equal to 150 kilovolts. Therefore, we get the RF value is 1.06 kilo ohm, from which we can calculate the value of CF. For the formula, CF is equal to R1 divided into C1 divided by RF, so that we calculate the value of CF, which is equal to 0.01 microfarad. Okay, now we are going to see the circuit diagram for the integrator. This is the circuit diagram for the integrator. Operational amplifier. In the operational amplifier, we are giving the integrator circuit in the feedback. With the resistance RF, capacitance is connected in parallel. The rest of the connection is same. Here we are giving R1 and with the non-inverting terminal we are going to give the input. Here we are going to give the square wave input and verify the output at the CMO. Similarly, for differentiator, we are going to give the connection. Here instead of R1, we are going to give resistance and capacitance series combination. Resistance value is 1.06 kilo ohm and capacitance value is 0.1 microfarad. Similar connection, we can verify the output for the differentiator. See, for the differentiator, if we give the input of the square wave, then the output will be the spike wave. For the integrator, if the input as a sine wave, then the output will be obtained as a square wave. For the integrator, if we give the input as a sine wave, then output will be the cosine wave. Similarly, we can verify for the various waveform. The application of this is we can use in a comparator circuit for cutting the value between a particular frequency, which we can use this. Now we are going to see the simulation output for this integrator and differentiator. Now we are going to see the multisim output for the differentiator. This is a circuit diagram for differentiator. In the differentiator, the input negative terminal is connected towards the RC combination, means series combination. Here is the input function generator. There we have to set the waveform. See here, we give the input in this terminal and take the output as this terminal. Here the green color indicates the input and blue color indicates the output. If we simulate the circuit, we can see that the if we give triangular wave as an input, then we get square wave as an output. Suppose we want to change the input as a, we have to change the input. We can choose this and we can select the waveform as a another one. Instead of triangular wave, we can choose another type of waveform such as sine wave, and we can see the output. If we expand this, we will get the various types of waveform. I just already seen that. See the schematic. We have to click this, and now we can wave this form, change this waveform according to your wish. If you give it as a sine wave, then it produces the cosine wave as an output. Okay. Similar manner, we can vary the input and obtain the output. Okay, next we are going to see the output for the integrator. Okay, this is the simulation output for the integrator. See that we have taken input as a blue color voltage and output as a green color voltage. If we give square wave as an input, we will get the triangular wave as an output. This is the inverse of the previous operation, that is differentiator. See, this is the simulation, live simulation. You can see the voltage as a square wave is given as an input. We will obtain this triangular wave as an output. Okay. This is the output for the integrators. Therefore, in the second experiment, we have seen the output for the integrator and the differentiator. Suppose we want to change the waveform, we can click this and we can click this source and we can change the waveform so that we can obtain the various output regarding to the input. Next, we are going to see about the next experiment. Thank you.